Hello everyone, welcome back to my YouTube channel Matrams. And today we are going to look at one of the amazing questions which I've ever solved for an interview, right? So without further ado, let's get to the question. As you can see that there's a duck at the center of the circular pond, and there is this hungry fox waiting nearby, just outside the pond. Obviously the hungry fox wants to feed on the duck. The catch is that the duck can only swim with the speed v, and this fox can run with the speed 4 times that of duck, that is 4v. So given this scenario, and given that the duck cannot submerge into the water and can fool the fox and appear out of nowhere, right? Cannot do that. And also the fox also cannot just become Superman and rather Aquaman and get into the pond and catch the duck, right? Can this fox eat the duck, or will the duck escape given such are the conditions? Take your time. I'll give you a few minutes. Maybe you can try it for a few minutes or something, and then get back to solution if you cannot get it by yourself. You may pause the video. Okay, so let's get with the solution. Let's get started with the solution. So I guess the first approach is to think that let's just see what time does the duck take to reach the opposite end. That is the best strategy, right? It can go anywhere, but it would obviously choose the furthest point from the fox. So suppose this radius is r. Therefore, duck will get there in a time r by v, right? And the fox has to travel this distance. So this distance is basically 2 pi r by 2. This distance is pi r upon 4v. Everybody knows that pi is equals to 3.14 and falana dimka, right? So pi by 4 is obviously less than 1, and therefore this time is greater. So the time taken by duck is greater than time taken by fox to reach this point B, right? Let's assume fox is at A, and therefore obviously the duck cannot escape with this strategy. So one might think that maybe duck can fool the fox, right? It will pretend to go this way some distance and then dash towards this opposite point, right? But in this case also, assume that it has traveled some distance x, right? So the fox would also be at some distance y. You're not concerned with the speed. Now, if he tries to dash directly back at A, now notice that when he is going back to A, when he reaches the center once again, right, when he has again traveled this distance x, the fox will also reach this distance y and be already here. So this strategy also fails, right? But now with this, we've got a very big hint how to escape from the fox. Can you see it? Well, I'll tell you. Now suppose he walks some distance x here, the fox will obviously be at some distance y. Now he is here and fox is here. What is the furthest away point from the fox? It is diametrically opposite to fox. This is the point which is easy for the duck but hardest for the fox. So now he starts going this way, right? And suppose he is not going all the way. Suppose now he goes some distance. Maybe let's note it down by x1 and this by y1. And therefore now he will go a distance x2, right, in this direction. So also, irrespective of where the fox is, the fox will have to take either this path or this path. Both the paths are equal. So let's assume he is going to this path, taking this path, and he covers a distance y2. Now again, if the fox is here, right, at say suppose point D. So now, what is the furthest away point from the fox? Diametrically opposite, right? So from here, now duck swims this way, right? So this way, this duck can minimize his distance from the shore, right? And it will be difficult for the fox to get to the opposite part of the diameter, right? So with this thing in mind, I got to know that it would be some kind of spiral motion would be the best case scenario for it. And that's where the circular motion comes into picture. I'll show you. So the best strategy for the duck to escape is, oh my God, Knuckle is back. Oh, just the fox would have just picked up the duck without the boundary, right? So now we know that duck's maximum speed is v, right? So by the analogy that I have given before, we know that at least it can reach to a circle of radius, suppose x, such that when he swims with a velocity v, he can always like make the fox go in the opposite direction. Suppose rather here, making it here, I'll make it here. Suppose he is going here with the speed v, right? He can force the fox to be at the opposite end and he'll go maybe this way, right? If the fox switches the direction, even duck can switch the direction. So let's assume that duck is going this way with speed 4b. So what is this maximum radius x? So we know that by rotation theory, right, or by circular motion, simply, you can state that their omega will be same when these guys are going into circles. So v by x at that point will be equals to 4b by r. From here we get that x equals to r by 4, right? So what I'm suggesting is that suppose this duck travels a very small distance dx, right? So as the fox can see that he is going to the opposite shore, he'll move a distance dy. But in the meantime, he also turns such that he is always going towards the point at the shore which is directly diametrically opposite to the fox, right? That way, the duck will have his back to the fox and he will like spiral out. He will spiral out and he can maximize his distance from the fox such that if the fox is at this point m, suppose, so this duck is r by 4 units away from the center, right? Or rather, 3 hour by 4 distance away from the shore. The fastest distance this duck can travel is this, right? The fastest or the smallest distance which it can cover is this, which will be difficult for the fox at this point of time. So now he has to travel. We have reduced the problem such that now he has to travel 3 hour by 4 distance, and his speed is v. So this is the time taken by duck, right? And let's compare it with the time the fox has to take. The fox will have to still take the pi r route upon 4v. So now, if you compare this, right? This is 4 pi, 4v. Now, if you compare, r goes away, this 4 and this 4 goes away, this v and this v goes away, and therefore we are just left with the fact that 3 is less than pi. What it means is time taken by duck would be less than time taken by fox. And so the duck can escape the fox with this strategy.
Ela vira mortal, de bom acaba que o clima da minha vara. Ela vira mortal, ela vira mortal, ela vira mortal, vira mortal. Ela vira mortal, de bom acaba que o clima da minha vara. Ela vira mortal, de bom.
I hope you guys enjoyed this problem. It was a very, very good problem. When I first solved it, it literally took me 15 minutes. It was a good problem. So do like, share, and subscribe my video. And I hope you enjoy it. Thank you.